It happens at 2 a.m. You're lying in bed, eyes closed, completely still. And then, out of nowhere, your brain decides to replay something that happened 11 years ago. A joke that landed wrong. A name you forgot in front of everyone. A trip on a flat surface with 30 people watching. Your body tenses. Your face flushes. You squeeze your eyes shut harder, as if that will stop it. It doesn't stop. Why does your brain do this? Why does it lock onto your most humiliating moments and replay them on an endless loop, sometimes decades after they happened? You can forget faces, names, entire conversations. But that one time you waved back at someone who wasn't waving at you? The answer is stranger than you think. Your brain is not broken. It is doing exactly what it was designed to do. The problem is that it was designed for a world that no longer exists. Here's where it starts. Roughly 300,000 years ago, your ancestors were living in small groups of between 20 and 150 people. That number is not random. Anthropologist Dunbar spent decades analyzing the relationship between primate brain size and social group size. The size of the neocortex, the thinking, social part of the brain, directly predicted how large a stable group an animal could maintain. For humans, that number landed at around 150. It became known as Dunbar's number. In a group of 150 people, everyone knows everyone. There are no strangers. There is no anonymity. Every action you take is witnessed, remembered, and discussed. Your reputation is not just a social nicety. It is a survival mechanism. If the group decides you are unreliable or a social liability, the consequences are not embarrassment. The consequences are exile. And exile, in that world, meant death. So your brain evolved a system. A very aggressive, very thorough system for tracking your social standing at all times. Psychologist Mark Leary studied what he called the sociometer, the brain's internal gauge for social acceptance. His research showed that self-esteem is not really about how you feel about yourself in isolation. It is your brain's running calculation of how accepted you are by the group around you. When that number drops, the brain does not send you a gentle nudge. It sends you a full alarm. Shame, embarrassment, social anxiety. These are not weaknesses. They are ancient warning signals. And what triggers those red lights most reliably? The moment you violate a social norm. Think about what embarrassment actually is. It is your nervous system detecting a gap between how you intended to be perceived and how you were actually perceived. You meant to look competent. You looked incompetent. You meant to look cool. You looked ridiculous. That gap sends a distress signal straight to your amygdala, the brain's threat detection center. And the amygdala treats it with the same urgency as physical danger. Because for most of human history, it was physical danger. The reason the memory locks in so hard comes down to a system called the emotional tagging process. Neuroscientist Joseph Ledoux at NYU spent years mapping how the amygdala interacts with memory formation, and what he found changed how scientists understand the brain. The amygdala does not store memories itself, but it acts like a highlighter. When an event carries strong emotional weight, fear, joy, rage, shame, the amygdala signals the hippocampus to encode that memory with higher fidelity. The more something embarrasses you, the harder your brain works to remember it. This is not a flaw. It is the system working perfectly. In an ancestral environment, the events most likely to get you exiled from the group were the events most worth studying and avoiding in the future. Your brain preserved them not to torture you. It preserved them because it fully expected you to encounter that situation again, and it wanted you to do better next time. The problem is that your brain has not updated its threat model since the Pleistocene. You are no longer living in a group of 150 people. You live in a city of millions. The person who saw you stumble off the bus this morning will never see you again. The audience at that presentation has already moved on. The friends who heard your joke go flat have forgotten it by dinner. But your amygdala does not know that. It cannot verify that the threat has passed. It can only do what it was built to do: flag the memory, replay it, analyze it, and prepare you for the next encounter. There is another layer to this. Research by psychologist Thomas Gilovich at Cornell University explored what he called the spotlight effect, the deeply human tendency to believe that other people are paying far more attention to us than they actually are. In a series of experiments, participants were asked to wear an embarrassing t-shirt into a room full of people, then estimate how many people noticed. Participants consistently overestimated by nearly double. The people in the room were too busy worrying about themselves to notice someone else's shirt. But knowing this does not stop the feeling. Because the spotlight effect is not a rational calculation. It is an evolutionary reflex. In a group of 150 people, someone always noticed. Someone always remembered. The assumption that you were being watched was adaptive. It kept your behavior sharp, your reputation intact, your place in the group secure. Your brain built that assumption so deeply into its architecture that no amount of logical reassurance fully overrides it. This is also why embarrassing memories feel worse at night. During the day, your prefrontal cortex, the rational, executive part of your brain, keeps the amygdala in check. It can redirect your attention, override intrusive thoughts, reframe situations with context. But at night, when you are tired, when the prefrontal cortex is winding down, the amygdala runs more freely. The guardrails loosen. The memory surfaces. The flush of shame hits you fresh. Even though the event is years old. Even though no one else remembers it. Even though it genuinely does not matter. Your brain does not operate on genuinely does not matter. It operates on, could this have cost you your place in the group? And here is the part no one tells you. The people who feel the most crippling embarrassment, the ones whose memories replay the hardest and longest, are often not the people with the lowest social standing. Research by June Price Tangney at George Mason University found that a capacity for deep shame is actually correlated with higher levels of empathy, more careful social behavior, and stronger long-term relationships. The same system that tortures you at 2 a.m. is the system that makes you considerate, trustworthy, and socially attuned. Your worst memories are the fingerprints of a social creature doing its job. That does not make it pleasant, but it does make it make sense. You are not replaying that moment because you are broken. You are replaying it because some part of you, 300,000 years deep, is still sitting in a group of 150 people, watching your reputation like a hawk, making sure you never make that mistake again. The world changed. The brain did not get the memo. So the next time it happens, 2 a.m., I shut. That memory surfacing like it always does. You can tell yourself something true. Your brain is not punishing you. It is trying to protect you. It always has been. It just hasn't figured out yet that you already made it out of the woods.